All right. Okay. So hopefully this is uploaded well, and you guys can now follow along and do the example that I had you write down with the demonstration of the titration. So let me just show you the equipment so that you can get ready to roll when we get into class tomorrow. I'll do a little explanation again. So what we have here is a special type of a clamp. It's called a burette clamp. And in here I have the burette. All right. So the burette is this long tube. It looks like a graduated cylinder. And it's got numbers starting at 0 at the top and going down to 50. So when I open this tap and I let the liquid through, I'm counting how much I'm using. All right? We'll put that back in the burette clamp. The other equipment that you're going to need are 3 Erlenmeyer flasks. They'll be out on the lab bench. 2 beakers of medium size. And I need 1 more little beaker for some water. So I'm walking across the way. This is just like real in class. This is fun. So I'm walking across the way and I'm grabbing another beaker for some water. You might notice on your beakers they're mislabeled. This says base and base. I want them to be labeled acid and base because I'm going to have acid in one and base in the other. So on your lab benches there are these magic erasers, and I can erase them and I can clear that off. I'm going to have some Sharpie markers out on the lab bench as well. So I'm going to write on here acid, and this one says base, and this one I'm going to put some H2O. All right? Okay. The H2O that we're going to use, you can just get out of the tap. So I'm just going to grab some out of the tap. Now, you're going to grab some acid and some base tomorrow at the specific locations in the lab as I instruct you. Tomorrow, the acid we're going to use is actually going to be a solid. So you'll put your Erlenmeyer flask on a scale. You'll add a little bit of solid. Make note of that solid mass of acid, and then we will get ready to titrate. Today, I'm going to titrate some sodium hydroxide, which I know the concentration of, 0.5 molar. And on that example problem, as I stated, you can write 0.50 molar. And in tomorrow's experiment, we're actually going to check to see if I got this right. So the experiment tomorrow is to check to see how well I was at making it. I'm going to titrate this against some hydrochloric acid, which I also know the concentration of, but I'm just hiding it. And I'm going to put that in the flasks using the pipette that I showed you the other day. We will need this for Monday, because on Monday we're going to titrate some vinegar, okay? So when you get your stuff all set, you will go to the station and grab, about, and it'll say how much, but about 40 or 50 milliliters of the acid and about 100 milliliters of the base. I have my jug right here, so I'm going to put in my 40 or 50 milliliters. Doesn't have to be exactly right. And I am also going to then take my 100 milliliters of the base. Okay. All right. And then I will return back to my lab station and I will get ready to prepare the burette. So the first thing we're going to prepare is the burette. And the burette is going to hold the base, the sodium hydroxide. Now, the way we prepare a burette is to rinse the inside of the burette with the base that we want to use, just in case the burette is contaminated with something that was in there from a previous use. So I'm going to take that burette and I am going to pour in about 20 or 30 milliliters. Now, I should have told you to check before. Before you do that, make sure that the tap is perpendicular so that the liquid can't get through. If I turn the tap parallel, it will run through. Okay. Now I'm looking on my video to see if you can see the sink, and you can. You can see it right off the end. You're going to have a waste container, or if you're close to a sink, you can do this in a sink. What we do is we turn the burette sideways with the mouth over the waste container or the sink, and I rotate it so that I cover the inside of the burette with the base. Now, if I had a little extra, I would open the tap and let it run through, and a very tiny bit is running through the tip. I hope you can see it on the edge of the video, and that's a good rinse. I'm going to rinse 2 to 3 times. I believe in the lab it says 3 times. I'm going to rinse twice here just for the sake of the length of the video. So there, I'm letting it come out the end. I'm opening the tap. I'm letting it run out the tap. I'm closing it. I'll turn the whole thing upside down over the waste container, open the tap, and let that liquid run out. Okay, so that's a rinsed burette. Now I'm ready to fill it in preparation for the titration. So I'm going to take my base, I'm going to use the lip of the beaker, and I'm going to pour that base until the burette is right full. So I keep pouring. I can keep an eye on it. There I can see it coming up. And I am going to load it higher than the 0 mark. There's the 0 mark right there, and there's the meniscus up there. I'm going to put it back in the clamp. I'm going to put my base beaker underneath, and I'm now going to open the tap so that the air bubbles are released from the burette. I will open it quickly, getting all the bubbles out. I will look back up. I can see I've still got lots of base in there, so I will slowly open the tap until the bottom of the meniscus is on the 0 mark. So remember, the meniscus is the curve that the liquid makes in the burette, and there it is touching the 0, and therefore my initial reading, down here the second one, for trial 1, my initial reading is 0.00, okay? Notice I have 2 decimal places, and that's because there are so many lines on this, I can get it to the nearest 1/2 of a 1/10 of a milliliter. So there are the lines which are the 1/10 of a milliliter, and if it's on a line, I get a 0, and if it's halfway between a line, I write a 5. Okay, so my burette is ready to go. I'm going to put my base off to the side. I'm actually going to move the burette a little bit. And now I'm going to talk about the acid. Okay, like I said, tomorrow you're going to put solid in this. You'll put it on a scale, tare, put a little bit in, write it down, because we're going to be using a solid. For my demonstration purposes, I'm going to be showing you how to titrate a liquid. So I'm going to use the pipette and a pipette pump, and I am going to take 10 milliliters, and I am going to put it into these 3 Erlenmeyer flasks. Whenever we do a titration, we should do it 3 times to check for repeatable data. Now, we need to prepare the pipette just like we would prepare the burette. I'm going to draw some of the liquid up. I don't have to get it right full. There, it's halfway. I'm going to pop it off and put my finger on it. And I'm going to take it out, and I'm going to go back over to the waste container. Now I'm turned sideways a little bit, but I'm going to rotate it and let it come out the top, and I'm going to let it rinse out the bottom. Again, we want to have a clean liquid inside the pipette, so I will do that 2 or 3 times, and for the sake of speed of the video, I will just do it twice. This time I put my thumb on the end. Again, I'm rotating over the waste container, letting it come out the back, and that is clean. So now I am going to prepare 3 of these to titrate. I draw the liquid up beyond the mark, which is right here, and I know my red lab coat is bad for this because it's hard to see. And I'm now beyond. I pop it off, put my finger on it, and I gently rotate and lift my finger as that level comes down. And like I said when I demonstrated this the other day, this is the hardest part of this whole thing. I've passed the line, which means that's no good. I've got to bring it back up above the line. And again, this is where I lose my patience. And I'm going to carefully do this time. And there it is there. Okay, so I'm going to draw this up so there's no drips. And I'm going to put it into flask number 1. So that's 10 milliliters of the acid. in flask number 1. And is it number 1? Yeah, labeled number 1. This one's number 2, and that one has also a number 2. I'm going to have to clean it off, put it as number 3. Again, there'll be a little bit of liquid in the tip of that. We leave it alone. I put that aside. I do it again. I'm going to prepare all 3 of them at the same time. Draw up. And I am only going to do 2 titrations instead of 3. You'll be doing 3. Again, I'm doing only 2 for the sake of the video length. Hopefully the video is not too long and too big of a file that it chokes over it. So again, I bring it down. The meniscus is on the line, and I'm putting it into number 2. Again, when it's done delivering, I touch the side to the side of the Erlenmeyer flask so any drops come off, and I now have prepared the 2 flasks, and I'm only going to do 2 trials. Okay, so in my table, I put how much base that I've put in. I know that I have 10 milliliters of the acid. That will come into play when I do my calculation in a moment. Now, when I mix this, I have to swirl it. And 10 milliliters is not very much liquid, so feel free, and it's part of the instructions, to add about 30 milliliters of water. This doesn't hurt anything, so that things can swirl better. I'm not adding acid or base. The moles that I need to react are in those flasks, and that's good to go. The last thing I have to add is my indicator, which is phenolphthalein, which will turn pink in a base. So I add 2 or 3 drops, and now I am ready to titrate. So I'll bring this back to the center. And again, unfortunately, I'm wearing my red lab coat, and therefore I'm going to impart some red color to this. Hopefully I can show it to you. I'm going to use a white piece of paper to put underneath so that when I titrate, I can see the pink color. I'll hold it up for you so that you can see it. All right? My burette needs to be positioned so that it is slightly lower than the top of the flask so that as I'm swirling, that I don't accidentally miss it. So I will open the tap and I will start to swirl. Now, you can't see this, but there's a little bit of pink happening while I add it. Don't know if you can see it there, a little bit of pink there, and then as I swirl, it disappears. All right? That's good. That means there's base being added and my acid is neutralizing it. I'm going to keep going until 1 drop turns this pink and it doesn't go away. You can usually go fairly fast at the beginning, and then eventually the pink won't disappear as quickly, and then you have to slow down. So there it's still disappearing. I know I'm not holding up the piece of paper. I apologize. I can't do both. The pink is starting to linger more, and I'm really bad at this because I don't have patience, and people who are patient are really good at titrations. I'm adding and swirling. Oh, and now the pink is really persisting and lingering. Ooh, I've almost added too much. There, you could. I don't know if you could see it, but that pink really was lingering. Now I'm going to open the tap up just a little bit and let 1 drop out at a time. Oh, and you can see there, 1 drop turned that really pink. That's actually too pink, so I didn't do it very responsibly. There's also a drop hanging from it. I can use my water to clean off that drop, and that, unfortunately, is not a great titration because it is too pink. We want a hint of pink. But that's what I have. At that point, we know it's neutralized. I'm now going to look at the number of milliliters that I've put into it. I can turn my burette so I can see the numbers. I'm going to put a piece of white paper behind this because my numbers are dark, and I'm not quite at the 10 milliliters. I'm a little bit past 9.5. No, I'm past 9.6, but I'm not quite to 9.7. So I'm going to write a volume of 9.6, but I'm not to 9.7, so I'm going to write 9.65. Okay. Now I can determine how much I used. 9.65, because I started at 0. Now you might think, why do I write it down this way? Well, I'm not going to reload the burette. My next initial reading will be 9.65. So I'm going to titrate my second one using my final volume from my previous titration. If you end up using a lot, like if you end up using like 20 milliliters, you've got to be careful, because after another 20, that will be 40, and you'll have to reload to do your third one, because this only goes to 50. And if you go beyond 50, you don't have the data, and you'd have to start again. Okay, now that I know it's at about 9.65, if I double that, that's around 18, which means I can go quite quickly down to 18. So I'm looking to see where 18 is. I'm just going to open that tap. I'm not even going to swirl. And I know it's going to turn purple on me a little bit. You can see it, but I am confident that I know I've got to get close to 18. So I'm going to stop at 17. I get down here to 17. There's 16, 16 and a half, 17. I'm going to turn it off. I'm going to swirl, and notice the pink disappeared. And that's because I know it's going to be close to that. Okay. Now I'm going to go drop by drop, nice and slow, and there it wasn't very slow at all. That's why I'm no good at this. I'm going to go drop by drop, and I'm going to see if I can get it a little bit of a lighter pink. Again, I'm in a little bit of a hurry because of I don't want the video to go long, and also I'm impatient. Who's kidding who? So there, the drops are persisting. I can see it. It's really persisting a long time now. Drop. Oh, drop. Oop, we're so close. That one quite disappeared. Oh, and if you're really good at this, drop. Oh, and not bad. That disappeared a little bit, but I've got a little bit hanging out. So I'm going to clean that bit off of there. I'm going to do my swirl. And that's not bad. That's a better pink than the last one. Little hint of pink. I like it. Oh, it's starting to disappear. So sometimes it does disappear. You need to have it stay for about 30 seconds. I'm going to need another drop here. And there I am back at that darker pink. That's unfortunate. It's not bad, though. It's quite dark, but it will do. All right. So there I've got, again, another dark one. But that's okay. Let's read my number. This time it's 19. I'm not to 19.5, but I'm past 19.3. But I'm not 19.4. So I'm at 19.35. Okay. So how am I going to get my volume this time? I'm going to subtract 19.35. minus 9.65 equals, and I get 9.70. Okay, this is good. We want our final volumes used to be consistent, to be close. All right. I want to do a third one, because ideally I want 3. But for the sake of the video length, I'm going to just do 2. Now at this point, because they're nice and close, I am going to determine the average volume of the NaOH, and that's going to be what goes in my calculation. So when we do our experiment, we've got 10 milliliters of the acid, and we've got an average volume of 19.65 plus 19.70. I add them up and divide by 2. If I had 3 trials, I would divide by 3. 9.65 plus 9.7 equals 19.35 divided by 2 equals 19.675, 19.68 milliliters of the base was used. Okay. I'm going to do the calculation here in a moment. I just want to quickly finish off telling you how you clean up your equipment. All of this stuff can go down the drain. You rinse 2 or 3 times. If it's the last experiment we do, I'll have you put them on the dishwasher. The base, again, can go down the drain. But something special about the base, sodium hydroxide is a solid. So if you don't rinse this with some acid, I will supply you with some vinegar to rinse. We need you to rinse with some acid a couple of times in order to make sure that all of the base that was in the burette was neutralized. So I rinse the same way I rinsed before. I will do that twice with acid, and I will do it once with water. So again, open the tip. Got to make sure all that base is out, especially through the tip. Turn it upside down, drain, and I will rinse with water once I'm done the problem and I've got the camera off. Okay, so now how are we going to solve the problem with this? Slide this over here. We're going to solve the problem exactly the way, and I'm looking at my camera, and I think I want to come this way so I can have a little more space. I'm going to solve the problem exactly the way I did before. In this case, it's NaOH. We're reacting with hydrochloric acid. This produces some NaCl and some H2O. This is already balanced, so our mole ratio will be 1 to 1. I know that I started with 10 milliliters of the acid. That's because I used the pipette to put the acid in the Erlenmeyer flask. And according to my information, I used on average 19.68 milliliters of the sodium hydroxide. I told you that I know the sodium hydroxide concentration to be 0.50 molar, and I want to find the concentration of the acid. Again, if I can get my moles over here, I will know moles, I know the volume, and I can calculate it. When I work with liquids, I can keep the millis. C equals N over V. Therefore, millimoles N will be equal to C times V, 0.50 times 9.68. All right, I'm going to grab my calculator. 9.68 times 0.5 equals 4.84 millimoles. 4.84. Our mole ratio is 1 to 1. All right, mole ratio is 1 to 1, meaning this is 4.84. C equals N over V. The N is 4.84 millimoles, and the V is 10.0 milliliters. The millis will cancel out, and when I divide by that 10, I get 0.484 moles per liter for my concentration of the acid. And I knew what the concentration of the acid was because I made it, and if I take the thing off, it says 0.5, so I'm hoping that's close to 0.5. Not bad, not bad. Okay. So that's how you do an experimental version of a titration. Once you get everything rinsed and cleaned, the burette goes back into its stand upside down with the tap open so everything can drain. If we are doing another experiment the next day, we clean up our lab station and we make everything look nice and neat after we've put our liquids down the drain and rinsed our containers 3 times, and then we are done. All right, then you can do calculations. Okay, hopefully this isn't too long and we can make it work on YouTube. Thank you very much.